Hello friends, in today's video we are going to learn about Euler's phi function. So Euler's phi function it basically counts the number of positive integers which are less than or equal to n that are co-prime to n. Now there are some formulas to find the value of Euler's phi function which we will elaborate now. First one is for prime numbers. So if we have a prime number, then the formula of Euler's phi function will be phi of p to the power a equals to p to the power a minus p to the power a minus 1, where p is prime and a is any natural number. Now let us understand this with the help of an example. Here I have taken two examples, one for phi 3 and one for phi 7. So it is pretty self-explanatory that 7 we have only 7 and 7 does not have any multiple power here, so it's 7 to the power 1, and as per the formula we have got the value of phi 7 and phi 3. Now what to do if in case of phi 7 or phi 3 it were phi 7 square, phi 7 cube, or phi 3 cube, phi 3 to the power 4. Now we will learn about those examples. So here as you can see, I have taken two examples of phi 7 square and phi 3 to the power 4, and using the above formula I have found out the values of phi 3 to the power 4 and phi 7 square. 7 square is 7 square minus 7 to the power 2 minus 1, and it gives us 42. Phi 3 to the power 4 is equals to 3 to the power 4 minus 3 cube, which is equals to 81 minus 27, which is equals to 54. These are pretty basic, pretty self-explanatory things, but they are very important because it comes in competitive exams like IIT JAM, CSIR-NET or GATE, or set exams that are held across India in specific states. So we have to learn about this. Now what to do if there are, suppose we have to find out the phi function of product of prime numbers, suppose phi 14. So in those cases what to do, right? We cannot use this formula anymore. So there is another formula in that type of cases which we will study now. So here in these type of sums where we have product of prime numbers, we will use the formula. We will first write it in phi of that product of that prime number form, and we will separate the two. Yes, we can do that. The formula allows us to do that, right? Because the formula is p1 a to the power a minus p1 to the power a minus 1 into p2 to the power b minus p2 to the power b minus 1 into ... as in the given question, and any number of prime numbers, for n number of prime numbers here in the formula we can deduce it, right? So we have taken the example of phi 14. So in 14 we have two prime numbers, product of two prime numbers, 2 into 7. Let's say if we have taken phi 70, right? Then what would be the product division of phi? It will be 2 into 5 into 7, right? And then we have to find out the value of phi 5, right? So in that case we just have to multiply 5 into phi 5, right? I will also show that, but let us first stick to this example. So in phi 14 it is equals to phi of 2 into 7, which is equal to phi 2 into phi 7, and then when we find out phi 2 or phi 7, we again switch back to the first formula. So what is the first formula? It is p to the power a minus p to the power a minus 1. So in case of phi 2, what will be the formula? It will be 2 to the power 1 minus 2 to the power 0 into 7 to the power 1 minus 7 to the power 0, which is equals to 1 into 6, and its value of 514 is hence 6. Now the example I was talking about, 570, let us find out that. So this was the example I was talking about, right? 570, which will be multiplied, or which is the product of three distinct prime numbers, which are 2, 5 and 7. So we first write it separately as 5.2 into 5.5 into 5.7, and we apply the formula of 1, that is that p to the power a minus p to the power a minus 1, and we get the desired result, which is 24, right? Now many of you may wonder that is this phi function or value of phi function is restricted to only prime numbers, a product of prime numbers. Can we not find the phi function of, let's say, 104 or 100 or 96 or any other number as per se? We can, and there is a certain formula for that, and now we will study about that only, that. So this number 3 formula is basically just an extended part of number 2 formula, right? The previous one which we did. So now in order to find the phi function of any number, we have to first divide it into, or write it in the product of primes, right? We have to write it in the product of primes. Like in this example 504, first I have written 104 in the product of primes, right? We get 5, we know that 104 is, what are its products? There are many products. One is 18 to 13, one is 52 into 2, and there is 104 into 1, but we have to write it in the product of primes. So this is one thing that we have to take care of, or we have to be mindful of. So after that, after writing in the product of primes, we use the formula in 1, that is phi of p to the power a, which is equal to p to the power a minus p to the power a minus 1, and we get the desired results. So these are some basic formula or formulae of Euler's phi function, and apart from that there is also another property, it's not a property as such, but it's an important trivia, that which is the value of Euler's phi function is always even if n is greater than 2, right? Why is this so? Why is this property formed? Because value of phi 1 is always 1, and value of phi 2 is also 1. Apart from these two values, you take any number in the world. If you take phi 3, its value will be equal to 2, which is an even number. If you take phi 4, its value will be equal to 2 square minus 2 to the power 1, 4 minus 2, 2, which is also an even number. Phi 5, value will be 4, even number. Just like this, you see here in all the examples we took 504, value is 48, which is even number. 570, value answer is 24, which is even number. 514, answer is 6, which is even number. So all the examples we took in today's video, we get to see the answer is even. So from this we can get to the conclusion that the value of phi function or Euler's phi function is always even for n greater than 2, right? Okay, so I've wrote down this statement once again, and that's pretty much it for the video. There is also another property which I would like to touch upon, and that is we will study about these in further classes. What is the terminologies that we are using, and it is, just remember this: phi is neither 1 1 nor onto. Okay, and what is 1 1? I hope that the persons who are watching this video, they all know 1 1 is injective, onto is surjective. So this is such just a little trivia that RS5 function is neither injective and nor surjective, right? So that is pretty much it for the video. I hope you liked it. If you have any doubts, please feel free to comment, and I'll catch you guys up in the next one. Cheers.